Welcome to today's webinar brought to you by Cockroach Labs. I'm Stephen Fegg, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled How to Architect Highly Available Apps for Scale in the Cloud. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we're excited to have Lee Acheson, cloud strategist and author of Architecting for Scale, and Andrew Marshall, VP of Product Marketing and Developer Relations at Cockroach Labs. Now I'm going to pass the event over to Andrew to dive into today's topic with Lee. Welcome to the broadcast, gentlemen.
Thank you.
Thank you, Stephen. And thanks for everyone for joining us today. Lee, I've been looking forward to this chat for a while. For our viewers, Lee and I actually worked together right around the time frame when Architecting for Scale was published, 2016-ish. And I feel like you and I have missed each other at events like reInvent and have not had a chance to catch up. So, I'll try to stick to our topic at hand as much as possible. But beforehand, I was going to ask you one question. I believe you and I talked about fly fishing when we worked together and sat near each other back in the 2016 timeframe. And I think fly fishing is now one of the official hobbies of the pandemic. So I was going to put you on the spot and ask you, how has your fly fishing journey gone, if it is going?
Oh my, no, it didn't go anywhere. So I'm sorry. I opened up with a disappointment. No, I started fly fishing and found I just really couldn't get into it. It's like the flies won, I didn't win. And so I did fool around with it for a while. I used to do regular, cast fishing when I was a kid. I still do that a little bit, but fly fishing was something new back then. I was trying out, and I just decided it just wasn't for me. So I haven't been back doing that since then, unfortunately. Mostly in the pandemic, I've been writing. That's mostly what I've been doing.
I believe that is the other hobby that everyone took up. That and making bread, fly fishing, writing, and bread. The big ones. So anyway, fair enough. And it's against the fly fishing code to say what rivers you live by. But for the audience, again, Lee lives in a very beautiful part of the world, and we'll just leave it at that in the Pacific Northwest. So. Anyway, moving on to the topic at hand, I mentioned that we worked together, in a previous life, right around when Architecting for Scale was published, and I may have been, in the large handful of folks who learned that the snail was the official mascot of Architecting for Scale early on, or earlier than others. And I just wanted to ask you, a lot has changed in the world, obviously, between then and now. But I'd love to get your thoughts on, what since you published the book originally has changed in the world of architecting, and especially in conjunction with achieving scale, and what's different in the world.
Sure, that's a good question. I think when the book first came out, the vast majority of applications were monolithic applications, and service-oriented architectures have been around for decades, but they really weren't common and they weren't mainstream in most applications. There were some use of services in some cases, and someone in the audience is going to say, "Oh, we use services," and lots of people use services, but monolithic applications were the norm. And I think that's probably one of the biggest changes that have been occurring is monolithic applications really have been going away and being replaced with service and microservice architectures. So that's probably number one. Number two is the cloud. Back in 2015, when I was writing the book, 2016, when it came out, the cloud was there, but it was young. If you were a major technology leader, you use the cloud, right? And so certainly we were using the cloud in various things we were doing with New Relic and obviously at Amazon. But, the mainstream rank and file enterprise wasn't on the cloud yet. Maybe there were groups that were using it for internal tooling, but it wasn't a mainstream tool like it is nowadays. So those two things are probably the biggest things: the acceptance of cloud of microservice-based architectures as being the norm for the way to build scalable applications, and the prevalence of the cloud as the way to build and support and operate modern applications at scale. Definitely those two things fit together. And of course, even back when the second edition came out, the term cloud native was a relatively new term. It's really been the last year or two that it's really become prevalent. But that's what we're talking about. We're talking about cloud native applications
here. Have you, since the cloud ubiquitousness of the public cloud and cloud native becoming a term, I would imagine the list of common problems that you would see kind of in a consulting fashion, or taking somebody out for coffee and talking about their challenges has changed. Have you seen some newer kind of scale problems emerge since the kind of growth of the use of public cloud, or is it still kind of at the core of the same issues?
That's a good question. There certainly are differences, but I think we're still in a transition phase here. While cloud native and microservice-based applications is the norm as far as new development, it's not where the vast majority of the applications are yet. So I think if you look at my clients and the people I talk to, well over half, maybe 2/3 of them, what they're struggling with is, I have this application that's a monolith. What do I do to bring it into the cloud? What do I do to modernize it and make it scalable so it can fit into this new world? And that means moving to services, means moving to dynamic infrastructures like the cloud. It means those sorts of things, but they're not there yet with their applications. So I think a lot of the effort that's still going in is the migration of the large-scale monolithic applications to cloud-native architectures. They've been lifted and shifted to the cloud, but that doesn't mean that they're scalable. That doesn't mean that they're taking advantage of the cloud. And I think the motion to the cloud-native architecture is really what's critical and still going on. That being said, there's still a lot of people who are developing applications new, but don't really know how to apply cloud-native topics successfully yet. Because they're still new to the whole concept. And so for them, it's mostly an education matter. That here's the way you build cloud-native applications. And a lot of it is around the processes and the infrastructures and the structure of the organization to support them as it is about the technology itself.
Mm-hmm. And have you seen, I know a topic you've spoken about quite a bit and actually researched is application complexity. I'd love to hear your thoughts on, after migration does take place, what are some steps that architects and technical teams can do to ensure application complexity doesn't spiral out of control? And also, I'd love to hear your thoughts on kind of applications complexity versus data complexity. What are the differences between those? What do people need to consider when building applications?
Good questions. Let's focus on the first one first. I think one of the true advantages of microservice-based architectures is the flexibility it gives the development teams, which means the ability to innovate and come up with great new ideas and great new concepts. And innovation increases dramatically as you move away from a monolith into microservice architectures. But the flip side of innovation is complexity, because as you give flexibility to developers, you give the ability to innovate. Guess what? They innovate. They try new things. They try new ideas. Sometimes they work, sometimes they don't, but they always leave some form of a footprint lying around. And whether you want to call it technical debt, whether it is technical debt or not, we can debate those terms. But it's the more flexibility you give in the development of the application over time, the more complexity you get on the back end, and that is, I think, a major problem that is facing a lot of companies that are building scalable applications. And so I talk a lot about, done a lot of writing in that topic, and I talk a lot about strategies for how to do this balance. How do you balance between innovation and complexity? And I think it's something that a lot of companies are struggling on, but it's an important thing that you keep focused on. You just moving in an innovative direction is great for the short term, but it doesn't give you a long-term supportable, scalable solutions.
This may not be a connection point that is worth thinking into, but I did have a question about do you believe that current kind of macroeconomic conditions and certainly greater scrutiny on IT budgets will lead to kind of more policing? That's probably not the right term, but more scrutiny on the amount of kind of innovation and perhaps application complexity that comes with it. Do you think that there will be some economic drivers to that, or has it always been kind of a technical issue and is fairly independent of costs?
Well, it's not just a technical issue. Like I said, the drive for more innovation comes from business need, right? And so that's where that starts from, and that innovation comes into the technical organization and gets converted long term into complexity. And not to say that's what developers do, is they switch innovation to complexity, but that's ultimately what happens. I don't think the economic forces change that dynamic, but what it might do is it might change within individual companies the push for innovation or the desire to fold back and say, now is not the time to innovate, now is the time to stabilize. And depending on the company and how it's affected by the macroeconomic scales, that change can affect what happens both in the short term and long term with your applications. You know, one of the things I'm wary of is companies that scale their organizations by large amounts when times are good, and then scale them back when they're no longer good. And that whiplash effect that goes on. It's not good for the employees, but it's also not good for the application. It's not good for the technical debt in the application. You know, you bring in a whole bunch of new people with great new ideas. That creates a ton of complexity that then has to be folded into a smaller organization and supported in a smaller organization. So you end up in the lean times with an organization that's in the muck and can't move forward. Point in fact, look at Twitter, and look at companies like that. You find that sort of muck happening a lot when you go through these large power dynamics. So that's one area where the macroeconomic conditions and the decisions that some companies, especially large tech companies, tend to make during those changes tends to have a negative impact on complexity. Companies, and I think Nintendo's a great example of this, that tend to grow a little bit, and Apple's another great example of this, grow reasonably during the good times, and then not grow, but also not shrinking during the down times. They're ones that are much more stable, and that leads to better innovation and less complexity in the long run.
I've always kind of felt part of your role as an architect is, I don't know, maybe this isn't the right term, but fairly political, or like consensus building and bringing various stakeholders to agree on a general strategy. And inherently the folks that you're talking to, be it software engineering leads or IT operations, have a job specific lens that could be very hard to organize. Do you feel like companies that you mentioned, the Apples of the world and Nintendo, who are growing at a measured rate during good times so that they don't have to reel things back, do you think that they have a better kind of three persona connect, or like, are all those groups working better together on a steady state basis, do you think, when that is happening? Or is it's still kind of like a challenge you're always going to have as an architect?
Sure. Yeah, that's a great question. I can't speak specifically about those two companies, about how well they work internally. I get the feeling that, yes, they do work much better internally, but I think that from a strictly philosophical standpoint, I think it's clear that the The more an organization has a stable plan and a stable track record and a stable growth plan for how it wants to grow and expand, the more stable that is, the easier it is to get everyone pointed in the same direction. Whether it's the architect who's trying to corral everyone together and go off in one direction, or if it's the development org or the business teams or the product teams, whatever teams we're talking about, it's a lot easier for them to all be focused in the same direction because it's been a consistent story and message all along. When you start doing a lot of flipping back and forth and saying, well, now we need to downsize for a while, we need to do this, we need to flip and change things around. And I'm not against you certainly want to right the wrong-going organization. If it's going the wrong direction, you certainly want to refocus and flip and change into a working organization. So I don't want to downplay that, but the more you do that, the harder it is to get everyone on the same page going the same direction, because the less track record you have as an organization in getting everyone going the same direction. Given that it's the architect's job to get everyone going in the same technical and technical related direction, not just technology, but in the business and the organizational structures that support that technology, getting people going in the same direction, their job becomes easier the more stable the organization is.
Mm-hmm. I'd love to dig into the philosophical aspects of the role a little bit more, but I would also like to go back a little bit and speak to, you talked about application complexity in contrast with data complexity. For the folks on the webinar, could you dig into what data complexity is and maybe some of the kind of modern considerations that teams need to think about in that regard?
Sure. Yeah. So, a lot of people, when they think about moving to service-based architectures, they think about the code and the responsibilities and the services themselves, and they don't think about the data. I've seen so many microservice architected diagrams that show a series of services all working together, talking to a single large data source at the bottom of all the data for all the services that all just kind of, in other words, they didn't take the time when they split their application into services, they didn't split their data into services. And it's just as critical that your data be architected and divided in the same way that your services are. I'm a firm believer in a very specific model that not everyone agrees with. So I'll be clear and upfront about this, but I think it's a model that's absolutely critical for a scalable organization. And that is the model where each piece of data is owned by a single service. The service is also owned by a single team, but only that one service can access this piece of data. Whatever that data is related to what that service does. Any other consumer of that data that wants to use that data cannot access the data directly. Instead, it needs to go through a published API to the service to request the data. So think of like a user profile service, and that's managing user profiles. Lots of people, lots of services within a application are going to use user profile information. And it's so easy to say, just make that data available for everyone to use. But no, what you should do instead is have all the requests for that to go through an API saying, give me the profile or give me this data, whatever, for this particular user, get the information and send it out, rather than accessing the data directly. So each piece of data should be owned by a single service and managed as a single piece of service. And that means your data is segregated, just like your services are segregated, and owned by services and service owners, just like every other part of your organization. So many times companies their data won't be owned by anybody. They'll have all of this data. Somebody will create the data, put into a place, and everybody will start using it. And then they want to change the data somehow and migrate it or motion or do something else with it. And they find they can't because they don't know who's using the data and what they're using it for. So they duplicate the data, or they change it in some other way but leave the old stuff around, and it becomes cruft and crud and just sits around and it gets out of date, or then they have sync issues, and all sorts of those sorts of problems occur. And all of that is because the data didn't have owners in the first place that controlled and managed who could access that data.
I'd love to dig into that a little bit more. So undivided data, obviously, you kind of articulated some of the challenges that immediately happen when no one owns it, or people are doing whatever is in their heart to get access to this data. But in broad strokes, what are the end user impacts that are fairly inevitable, do you think, when you're using that single source of data without attaching it to a service? And part B, what are the organizational issues that you're eventually going to have to clean up if that's the choice that you made as well?
Yeah, well, I mean, in many ways, it's the same sort of problems that occur with the monolithic application. What happens in the monolithic application is you have modules that don't have clean interfaces between them working with each other and interfering with each other. And you end up with problems where small changes have large ripple effects. The exact same problem occurs with the data. If your data isn't segregated, if your data is a monolithic data source, you have the same problems. You start depending on a piece of data looking and acting a certain way until someone else decides it needs to look and act a different way. And then that affects you, it affects everyone else who uses it, and all of those problems are just like technical debt in the monolithic application, they're technical debt in the monolithic data source. Is that what you were asking, or did I miss your question?
Yeah, it is. And other than attaching the data to the team and the microservices you mentioned before, are there some, maybe there aren't, are there some other best practices that teams can think about when they are architecting in that specific way to prevent all these issues that maybe are not on the surface?
So let's see. There's a bunch of different ways we could go with this. We could start talking about clustering of data and scaling data sources and some of those sorts of things. I don't think that's where you really are headed in this, and that's certainly, or maybe that's the direction you want to head. There are databases that handle a lot of that. I mean, CockroachDB is really good at handling those sorts of scaling problems for you. The problems with scaling with data have to do with how the data is used, who uses it, and how it is managed. That's where scaling problems occur with data. It's not about the size of your database. It's not about the horizontal scalability of your database. It's about how the data is used, because that is what impacts your ability to scale the application, is by the limits of the data scalability that goes into how the data is used. Again, I'm not sure if that's exactly the direction you're looking for with the question. Maybe you want to try again, or we can ask it differently, or we can go on.
That was kind of what I was asking, and I would also like to kind of continue down the road of the theme of how things are different now than they were in 2016, and maybe have you put on your prognostication hat a little bit. How will architecting for scale look in, let's say, 3 or 4 years versus where we are now? Like, obviously we saw a big jump in the common usage of public cloud, the quote unquote as a service model, cloud native being a thing. Looking at the vector that we're on now, what will be the next chapter of architecting for scale look like in that 3 or 4 year time frame?
That's a good question. One of the things I think a lot about is the role of machine learning and AI in scaling systems and how all that works. And certainly data is at a center of machine learning and AI. And one of the, I think there isn't a person here who doesn't believe that AI is not going to be centrally important to most applications in the near future. Already is for a lot of applications, will be soon for a lot of other applications. But there's kind of a fundamental problem with how we're dealing with AI right now that we need to think about. And that is there's a dichotomy in how people think about data and how AIs think about data. When people think about data, or people think about problems in general, data represents information towards a problem that has to be solved. When you think of it that way, people like to segment and separate and divide and to focus in order to solve problems, right? More data isn't necessarily good for a person making a decision. The right data, the right segment of data, the right information they need to make a particular decision is what's important. And dividing data and dividing decision making and dividing decisions, period, is the way humans work. And this whole model that I was talking about of microservices and microservice data is all based on that model of the way people think. People want to focus on a problem, let other people focus on other problems. AI and machine learning does the exact opposite. AI and machine learning assume that data is good, more data is better, so give me all the data I possibly can and let me figure out what I can from that. And so the whole mindset that we're using in our AI methodologies right now as our technology world is to treat data in a way fundamentally different and opposing to the way humans think about data. I think we need to solve that medium term, meaning next several years. I think we need to be thinking about, do we change the way people think about data to match the way AI needs to think about it? Or do we change our AI strategies to more align with the way that people think about things? And I think that's a problem we haven't solved yet. We need to.
Very interesting. And I would imagine that, with those two possible scenarios, kind of the quality control aspect of managing data is probably top of mind as well. So is that another area that we need to think through in terms of ML, and especially in the realm of software development?
Yeah. I think the data quality absolutely is, as the quantity of data increases, the quantity of data increases, the quality of data goes down. That's generally a true statement. But the more attention you pay to the data, the better the quality you can increase the data as well too. So I think one of the problems with this strategy that we talk about the more data is better that AI uses, is we don't have any indications about the quality of that data. And so we can have AI engines making bad decisions, but they're making decisions based on data, but it's not decisions based on valid data. And that's, I think that's a problem actually that OpenAI has actively acknowledged that they have with the current ChatGPT implementation, for example. There was some early, when that hype started up, there were some early discussions that a lot of the answers were just plain wrong, but they were very positive about the wrong answers. And a lot of that came from the fact that the training that they did was not quality controlled. And so they didn't have a good understanding of whether the answers that the lessons that the AI was learning, whether or not they were the right lessons or wrong lessons. And they ended up learning a lot of wrong lessons. So I think that's all about data quality. And so, how do we solve that? I mean, we need, I guess that's a whole webinar right there. And how would we solve data quality? I'm not sure if we want to get into that here or not, but certainly there's 1,000 different ways to do that and lots of different thoughts about that. But that is a problem in general with the same AI strategy of more data is better. More data doesn't necessarily mean better data.
We'll do a follow-up webinar on that because I would like to dig into that with you, especially with what's in the news in the very recent past. You didn't mention this specifically, but I had a kind of a selfish question on how do serverless architectures factor into where you see things are going and agility building with microservices and building cloud native applications.
I have this strong feelings around serverless. It dates back to the hype that went on with serverless when it first came out. You have no idea as when serverless really started to gain hold. By serverless, by the way, we want to make sure we're talking the same thing. We're talking about serverless computing, like Lambda, things like that. I mean, there's lots of serverless cloud services. S3 is a serverless service. We're not talking about that. We're talking about things like Lambda as a service. One of the problems I ran into is I had so many people rush up to me at conferences, at trade shows, who read my book or listened to me and says, guess what? We just built our whole new application. We built entirely in Lambda because Lambda is so cool and so great and removes all the problems with the infrastructure. And so we just built everything on Lambda and we're so happy. And every time I hear that, I groan inside because it's like, Lambda is a great technology for what it's designed for, and it's horrible for what it's not designed for. And one of the things it's not designed for is as a replacement for computation. Okay, it's great for a certain class of problems. A lot of them having to do with small transactional event-based things that have to occur. But as a replacement for general computation, it's not very good. And the main reason for that is it doesn't remove any of the complexity that comes from building a server-based infrastructure. It just moves where the complexity is. You now have to start thinking about things in different ways, but it's just as complex of a problem, in some ways more complex. And so, serverless will have a role and does have a role in building IT infrastructures today and building microservice-based architectures. It is not the solution to having servers lying around. I'm very much a fan of the traditional cloud native Kubernetes Docker-based, the object dynamic object motion and with built on top of dynamic servers. I'm very much in favor of that architecture in general for most of what an application does. And things like Lambda and serverless have specific use cases in that make sense, but not as a general computation engine.
Got you. And thank you for that, Lee.
Talk about serverless before, so.
I have, yes. Yeah, I may have, one of my first conversations about it might have been with you. So very interesting. And it looks like we've got some great questions popping up. So I might turn it over to Stephen to cover those.
Fantastic. Thank you very much, Andrew. So first question for you, Lee. What's an example of flexibility that gets people in trouble?
That's a good question. So flexibility from the standpoint of, let's say, of trying to innovate in an idea. What tends to happen is, you'll try one solution that'll partially work, partially not. You'll try a little bit different solution. You'll try a little bit different solution, but you end up with artifacts of those old solutions lying around. So the end result is you're creating a trail of complexity, because the more things you have to worry about, the more complex the system is in general. And simply since you're able to be more flexible and able to try and do new things, you're not always cleaning up everything that comes from it, and you end up with a more complex solution. So that's a very high level, and there's a lot of but what if that can go on in that. But I think most people understand that if you keep trying something a little bit different in an application, it's going to end up with small pieces of all of that in the application, and the breadcrumb trails of all those different things you've tried all add up to create a more complex solution than if you have something that doesn't do that approach. So, that's the flip side of innovation, right? Innovation is good and great, but it gives you this complexity you have to deal with.
Understood. Moving on, Lee, what is one mistake that you'd really love people to stop making?
Well, we talked about serverless. That's a good one. Let's see if there's other ones. I think, more recently, hyped technologies in general. I see a lot of people jump on hype technology bandwagons very, very, very quickly. And while that's great in, highly innovative areas, and we're talking related to that, it comes back and haunts you later. And that we talked about that with serverless, and serverless hype, I think, is what drove a lot of people to make those decisions to use serverless everywhere, and then end up with the complexity that came from that. But I think we're seeing that this month with ChatGPT and the hype that goes with that. People keep talking about AI is ready to replace everything that we do, and we don't need writers anymore. We don't need programmers anymore. We don't need artists anymore. We've got ChatGPT. And I think I'd like to people, if you're looking for things that we don't want people to be doing, I don't want them to put everything into the hype, because the hype is almost always not correct.
Understood. Next question. Do you have a recommended tech stack for startups that are thinking about scale from the start?
Oh, that's a good question. First of all, I'd say definitely use, for the base application architecture, use a cloud native application architecture. So I'm talking about, small services built in, Docker style containers that are running on a orchestration system like Kubernetes. That model, that mindset is a great to build a scalable system from the beginning. I want people to think and build their application with scaling to start, because it's so much easier to build a application and the organization that supports it and builds it around it. It's a lot easier to build that from the beginning, and it's a lot harder to build that later on. Now, this goes against the whole idea of MVPs, right? When you want to do an MVP, minimum viable product, you want to do the least work possible. And this, building a cloud native application architecture takes some work before you do anything, right? And so if you do need to build MVPs, treat them as prototypes and throw away code, and don't make an MVP the basis for your long-term infrastructure. So that's number one. Use cloud, build a cloud native infrastructure from the beginning. The other thing I would have people look at is look at what AWS has defined with their well-architected frameworks. Now, whether you use AWS or not is irrelevant, but look at their well-architected frameworks and understand those. They give you a lot of best practices for how to use dynamic infrastructures in cloud-based environments, and that is going to help a lot. Now, as far as the specifics of the tech stack, whether or not it's it's Go based or Java based or whatever it's the server technology is, or for that matter the client side technology is, less critical. But I think it is important that as a company you build the sandbox with the right guardrails in place that says, here's what we're going to allow you to use, and then let developers innovate within the sandbox, but have strong guardrails where the edges of the sandbox are. And if developers want to go outside of that sandbox, then that needs to be a whole process and a whole discussion about does the sandbox need to be expanded, or do we need to make exceptions or whatever. But let developers innovate within the sandbox. And specific choices of languages and frameworks and things like that can be definitely within most sandbox frameworks.
Understood. Next question, Lee. If data complexity is falling on the shoulders of architects and CTOs, what are ways that you recommend they keep track of the complexity and stay ahead of big problems?
Well, complexity will show up as stagnation, or projects will start taking longer to implement, and they'll start requiring longer testing cycles, and they'll start requiring longer, more problems prior to release, and delayed schedules and things like that. Those are signs of a complexity within your existing architecture. Where we're talking about application architecture, data architecture, doesn't matter. Those things are signs that problems are occurring. So that's as far as metrics to look at. Those are the sorts of metrics as an executive that I would pay attention to. Are your developers nimble and able to come up with great ideas and keep things moving, or have you bogged down in problems and issues in the ability to get a job done?
Okay. Another question, Lee, is there anything in the book that you've really changed your mind about since writing it in 2016 or updating it in 2021?
Oh, geez. That's by far the hardest. I've done a lot of these interviews. That's by far the hardest question I've ever heard. That's a good question. There's certainly a lot of things that my views on it have matured and grown since I wrote the book. I don't know if there's anything that I just say, no, I completely disagree with than what I said back then. I think a lot of the early cloud information I put into the first edition is just out of date. And so the second edition proves a lot of that. So out of date would be things I would disagree with. I think I focused a lot on risk management in both editions of the book. And I think in some ways I maybe focused more on that than I should have. Not saying I disagreed with what I said as much, but maybe I put too much emphasis on that. I think a lot of people are already, and maybe that's a sign that I don't need to focus on it. The third edition could focus on that a lot less. But I think if I were to do it over again, maybe I would have a lower focus on the risk management and higher focus on some of the other areas. I think the timing of the second edition was a little bit early for the whole cloud native model. And so what I talk about is very much a cloud native architecture, but I don't use that terminology because that terminology wasn't really as mainstream as it was. Remember, I wrote the book, it came out in 2021, but I wrote it in 2020. So cloud native really wasn't in the mainstream vocabulary as much as it is now. So I think I would be using that terminology and the terminology used by the Cloud Native Computing Foundation a lot more than I currently am. And so some of the terminology I would change. I talk a lot about STOSA, but I think I would have put a lot more emphasis on STOSA. STOSA is a single team-oriented service architecture. It's the model of how you build your organization so you have ownership of individual services and the data that goes with that, and how the interactions work, and how do you manage SLAs between teams and some of those sorts of things. I think while that was an important concept in both books, I think I would have focused on that significantly more in both books than I did. So that's a change I would make. None of those are really disagreements, maybe, or things where I've changed my mind on, but there certainly are decisions I made when I made the book that I would have done differently now.
Understood. And why don't we end on an easy question? And Andrew, feel free to weigh in with your views as well. But Lee, if there's one thing you'd really like our viewers today to walk away keeping in mind, what would that be?
I think the biggest thing is to realize that building scalable applications is not something you throw on at the end. Building scalable applications requires building organizations that know how to scale. They mean building processes and systems and infrastructures in place that allow you to have a scalable application. It's not throwing servers at a problem. It's having a mindset that allows you to build an application that scales. And that's not only from the number of users that are using it, but the size of the application itself and the number of people that can develop and support it as well. And so I think the biggest thing I would say is have that scalable mindset and think about scalability as a critical component of everything you do within your product from the very beginning.
Okay. Well, listen, I would like.
I'd love to hear Andrew's view on that too. I'd love to hear
yeah.
Andrew's
I'll
view too on it.
I'll plus one that. I love that answer. I would extend that into thinking about, beyond architecting. I think you need to think about business goals such as resiliency. Obviously, we talked about scale, consistency, and then the kind of footprint of the users of your application, be that global, and what regional factors go into that ahead in the same time frame that Lee just mentioned. These are things that can't be left to the last minute, and obviously that's easy to say from this vantage. And things are moving rapidly, and it's very hard to build modern software. But the earlier you think about those resiliency, scale, consistency, locality considerations, the better off you'll be.
And yeah, that makes a lot of sense. And I just want to echo that. We talked about scale, but usually when I talk about scale, we also talk about resiliency and availability. And we really didn't talk about that much. So Andrew, I'm glad you brought up resiliency, and I'll also mention the word availability as well in that.
Okay, well, I would like to give our speakers today a huge thank you for coming on board and sharing their insights and expertise. Once again, Lee Atchison, cloud strategist, author of Architecting for Scale, and Andrew Marshall, VP Product Marketing and Developer Relations at Cockroach Labs. So if you would like to review this presentation or send it to a colleague, you can use the same URL that you used for today's live event. It will be archived, and you will receive an email notification from us once it's posted. And again, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on January 31st. We'll let you know if you are the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.